The rules of Game of Life are very simple. If we have a living cell, we firstly check if there are some neighbors around it. If there are no neighbors there, it will die. And even if the cell had a neighbor or more than 4 neighbors around it, it would also die. But if the cell is surrounded by 2 neighbors, it would live till the next generation. This and that cell will live in the next generation because they both have 3 neighbors around. What happens to the other cells here? Those 2 will die because they don't have enough neighbors to live. In the next generation it will turn again to its previous state. Now, can you explain why? This will spin again and again. Now I would like to show how the Game of Life looks like in the code. Let's start with the bottom of this project. Here you can see I described a struct named fontStyle. At the construct we set the color and the character, so I can use it in the struct for the cells, as you can see here. If the state of the cell is set to alive, then we return a dark green O. If the cell is dead, then we basically return nothing because it's dead. So we ended up in the cell struct. What's going on here? And again, I'm using a struct just because I want to assign, for example, a cell 1 to cell 2 without pointing to the actual cell 1. You can't achieve that with a class, it will always point to the same place. A cell has a state which is an enum over here. The cell can be dead or alive. It also has coordinates y and x which are read-only, and the coordinates can be null. I can only assign those fields in the constructor. Moving further, outside the struct we have two two-dimensional arrays. The first one is the current map and the other one shows the previous state of the cells, so we can compare those 2 states with each other. But doesn't it work with a single map? Why do we need even 2 maps, you may ask? And here's the problem. If we change the state of the cell to dead, the next one will be also dead because it doesn't have enough neighbors to live. So the next one will probably also die. But this is not what we want. Then I have 3 private integers. The width and the height are the size of the map and the window size. The generation variable says how many times the cell's overall state has changed. And the duration says how many milliseconds we have to wait until the cells can move again. Moving finally to the playground constructor, where we assign our 2 two-dimensional arrays. We also set the window size here. After that we are calling our first function draw. Let's look for the function. Basically the function allows us to write our own map out of cells. In case we press space, we draw a cell into the map. In other case, if we press any of these keys, we change the cursor coordinate, but before doing that, we check if we can draw on the given y and x position. Then remove the previous position on which we were standing on. Otherwise the coordinate changes anyway. And then finally outside the switch we draw the cursor on the given position. This all loops until we press enter. Moving on to the update function, since we are calling that after the draw function constructor. Update is an endless loop. In the loop itself we are calling the nextGen function to update the next generation. And again, we are looping each of the possible coordinates and applying a new state for the cells from the rows function with the y and x parameters. So as the function says, we are checking for rows here. I've already explained the rows, so I don't have to explain this in much of a detail, but I can show how I count for the neighbors around the current cell. So if the cell in the given coordinate is alive and the coordinate isn't out of the bounds of the cell's map, then we can count this as a neighbor. And then according to the amount of neighbors we do the rows. Back to the update function, we can see a redraw function. This function is for drawing the state of all the cells. We check here if the cell does even exist. If not, then we can continue. After that, for the sake of optimizing, we check if the previous cell state isn't equal to the current cell. If not, then we draw the cell. After that, we wait for a duration and then we make all over again. Next gen, redraw, wait for a duration. Next gen, redraw, wait for a duration. So let's transform this into a 2D pixel kinda game of life. I actually programmed an engine before just so I can use all the OpenGL necessary stuff easily. Here are some test examples of the engine. So that's it for this video. Like and subscribe, comment on this video if you like to. Bye.